Hello and welcome. I'm Nick Jacobs, the Spring 2017 SpiderBot Project Manager. Let me introduce you to the rest of the team.
Hello, my name is Sean Pazos. I am the Electronics and Control Engineer for the SpiderBot project.
Hi, I'm Daniel Matias, and I'm manufacturing.
Jefferson Fuentes, MST.
The intent behind SpiderBot was to provide a live aerial video feed to the RX Terra control panel to enable Biped and Velociraptor to navigate a Pac-Man style end of the semester game. To do this, SpiderBot incorporated the 3-dot controller, a custom PCB, grappling hook, and winch motor system. After about a week of research, we found the Terra Spider design. We stuck with this design since the customer's specifications only permitted the use of DC motors to drive walking mechanisms. Absolutely no servos allowed. The Terra Spider design is a true spider consisting of 8 legs, only being driven by 2 motors. Needless to say, this would be our strawman design, otherwise known as our starting point. The great thing about the Terra Spider Instructable is that it came with design files. Having pre-made CAD files along with documentation on getting started allowed us to cut acrylic and build our first draft in the same week. This also came at a price. One huge blow to our ego was the cost of our initial laser cut. You can read more about it by clicking the link in the description tab below titled The Cost of Learning. The customer also required that our design incorporate a custom PCB. The 3-dot board has the ability to drive 2 DC motors. That's it. The need for SpiderBot to provide an aerial view required a 3rd DC motor. Our custom PCB consists of an additional motor driver to power the winch motor and a PWM expander that allowed for the custom PCB to communicate with the 3-dot controller via I2C. Hats off to Westimation. Not only did he create the Westimation miniature winch, but he was also kind enough to reply to my emails when inquiring about his design. We took his design and modified the gearing ratio to enable us to elevate SpiderBot, at this point weighing 750 grams, 64 inches into the air to provide an aerial view of the 3 by 5 foot maze below. You may be thinking, how did SpiderBot get up there in the first place? This is where our grappling launcher came into play. Daniel, our manufacturing engineer, designed a tension release grappling system, and Jeff, the systems engineer, found a latching mechanism that allowed us to remotely fire the grappling hook using a 3.3 volt servo from the RX Terra app. Finally, once all the subsystems were in place, Jeff, the systems engineer, devised a validation plan to thoroughly test every aspect of SpiderBot's functionality.